This is day 2 for me in terms of my practicing for lead code questions. Today's question is question 1760, minimum limit of balls in a bag. So it reads, you're given an integer array nums where ith bags contains num I balls. You are also given an integer maxOperations. You can perform the following operation at most max operation times. Take any bag of balls and divide it into 2 new bags with a positive number of balls. For example, a bag of 5 can become 2 new bags of 1 and 4 balls and 2 new bags of 2 and 3 balls. Your penalty is the maximum number of balls in the bag. You want to the maximum number of balls in a bag. You want to minimize your penalty after the operations. So generally we have bags and want to separate them and find the minimum number of bags. So the example is num I, max operations is 2 and our output is 3. In this case we split the bag 6 3 and 3 3. And then example, the constraints 1 to the power 10 to the power 5 and the max operations 10 to, which is important, not really important in this question. So I'm gonna remove this from the previous video. I tried recording a video and then there was a phone call, so I had to restart. So from what we can see, this problem, if you haven't met a problem that's similar to this one, this seems like a hard problem, but actually it's a medium problem, meaning it's actually doable. But if you haven't met a similar problem, it's actually difficult to come up with a solution. But let's think about it. In order to think about a problem, the first thing you think about is the brute force. So force approach, in this case the brute force approach, you probably want to go through all the options that are there. You want to split all the bags and find which bags you can split. But as you see, how do we know we're going to split 3 bags, 6 by 3 or 4 by 4 or any number of bags? Like in this example, how did they know that they're supposed to do 6 by 3, 5 by 3, or any other split that we can do, which makes it a bit tricky in terms of solving this problem. But how? So instead of mimicking what's happening, what we could think about is finding actually the max number of bags. Since we have this max operation, we can actually find the number of balls in the bag, or the max number of balls in the bag, and actually trace from there how many operations it takes to get to that particular max number of balls. So in this case, we get the max number of balls in our array nums. So we get 1 2 3 4 5 6 7 8 9. Then what do? We say let's start with 8. Let's say 8 is our number. Then we divide 8 into 9. Then what do we get? We get 1 point something, right? So I don't know, 1 point something, it's 1 point something. So then what we do, this tells us that to get to this particular number, we can do it in one operation. So what we generally do is we say plus 1, we round up, so this becomes 2. Then then we subtract the 2 minus 1 to get the number of operation. Then we do the same until we get to a point where it actually takes more than the two max operations that we need. So in this case, let's say we get to 3 into 9 is like 3, then plus 1 minus 1, that becomes that that becomes 3 minus 1, that becomes 2, which is the correct answer. But if we get to 2, where we say 2 into 9, we get 4.5, which becomes 5, but we subtract 1, we get 5. So at most this is the correct answer, which is 3, which is our output. So now that gives us an ON solution, because we're going through all the numbers. But as we know, there's something that we call a binary search, where we can actually search for this point. Instead of going through the whole numbers, we actually search for this point, and then when we find it, we return that, which makes it, since it's a binary search, I'm going to call it BS. Alright, let me just call it binary search. It's log n in terms of our search, because I think this is an issue for a different day, where we can delve into what a binary search is and how it works. So a binary search, so usually before you start these questions, you actually need to polish up your data structures and have a greater understanding, so that you can apply them in this situation. So in order to understand this problem, it makes sense to get into the code. So at first, we've got our low. So this proper structure of a binary search, we have a high, which I'll call 0 for now. I think we'll get back. So remember, our numbers are positive numbers, so we're gonna start from 1, our low. Yeah, we don't need to 0. So we don't need to start from 0 like always. So high. So now we're gonna find the highest number in nums. So just gonna do a quick high equals high less than low less than num, then num becomes high, else high just remains like that. So we've got our highest number. So now when I do a binary search, which is from high, which is where, so while low is less than high, then the loop continues. This is a binary search structure. I usually prefer to put my return statement before I do a lot of things, so I don't forget about it. And my return is high. So now, what's the first thing? The first thing, we need to get our mid, which is a calculation where this proper binary search, we want to find the midpoint that we're predicting. That's where our point is, divided by 2, we get this midpoint. Then now we loop through the whole array. Remember, we might have multiple values, so when I check how long each operation takes for us to get to that mid number. So for int num in nums, right, put it here. So before, what I'm gonna do, when I int num of ops, so this will keep the number of operations that we have performed, so that it helps us in our binary search. All right, so num of ops plus or equal to sum. So we are dividing into num by mid, wanna divide into num by mid, then num by mid, yes, num by mid. All right, num by mid, num by mid. Okay, so num by mid. Alright, so num minus 1 divided by mid, okay, because we want it to round up. And then we move outside. We, after the search, want to check if our num of ops is greater than, is less than, let's start with less than, is less than, I think that's max operations. Max operations else. So in terms of logic, so num, if num of operations is less than the number of max operations, that means we can actually move further down. So meaning our high equals mid, and then we can also, if not, we can say our low is equal to mid plus 1. So we normally need to consider that particular boss have understood that it's actually more than what we need. So all right, so now I'm just checking if there's something that we might need. Okay, so this must be our solution. This is our solution. Just double check, you go through all the whole code, and then we should run it and see if there are errors. All right, I forgot to remove things on top. All right, so see what happens. Oh, there's a full stop somewhere. Okay. All right, so past our first test case after removing the errors, then if we submit, see what happens. So this is our solution, passed 99% of the time. See you tomorrow, day 3. Looking forward to day 3. Almost missed today, but yeah, thank you very much for watching. Please do subscribe, please do share in the comments if the things that you might need to understand more, or any additions to the solutions.